This lesson will serve as your notes for how to do lens ray diagrams. And to do these notes, you need to have this piece of paper handy. If you don't have it, you should be able to download it from my website if you didn't pick it up on the last day of class. Also, if you have this handy, that would be a good idea. This is a lab we did a few days ago, and I'm going to reference this a few times. You'll also need a ruler to do these notes for today. And when it's all finished, you'll need to, on the next day of class, bring in these notes completed, and you also need to fill out a Google form on my webpage just so that I know that you actually took notes and you did it. So we're going to use ray diagrams again. Remember, we did ray diagrams before with mirrors, and ray diagrams just help us locate the image of an object when it's viewed, in this case, through a lens. And this is how you do it. So in our lab we did a few days ago, we looked at convex lens like this one, and we looked at the light that came in it. We found that parallel rays of light came in, and they bent toward the focal point. I'm going to show you that. So I'm going to draw a parallel ray of light that's coming towards this convex lens. And you know from what we've done in class that this light ray hits the lens and it bends, according to Snell's law. Now, I don't want to pull out a protractor and find the tangent and anything like that to figure out this angle. So we're going to have some special rules to do it. But we do know that this ray of light bends toward the normal, and we can see that if you think of this ruler as a big fat ray of light like we talked about in class. As this comes along here, the ray of light down here, this slows down first while this is still going fast, and the whole thing is going to kind of bend downward, so that as I draw this ray in here, have it bend ever so slightly downward. Oops. Then when it hits this surface, again think of the big fat ray of light, and we know that the bottom portion of the ray of light is still inside the lens while the upper portion leaves. So this is going to go fast while this is still going slow, and the whole light ray bends again. And we know that it goes towards the focal point. We found that in our lab the other day. So this time we can have the light ray bend right toward that focal point, just like that. So the light ray goes through, it bends twice before it gets to the focal point on the other side. And you may even want to label that as F for focal point. I should mention at this point that if I'm going too fast, feel free to watch the video again or pause it so that you can get everything that you need to get. Now, we looked at lots of parallel rays. Here's another one. You can do this on your own even. A ray of light that comes in parallel to the principal axis. In this case, the top portion of this big fat ray of light would hit the slow part, the lens, first. This would slow down. This part of the ray is still going fast, and the whole thing bends upward. So it's going to look something like this. And again, when it gets to this side, it's going to bend again. This time the bottom portion will speed up first because it leaves the lens into the faster medium, whereas this is the slower medium. And it's going to bend right toward that focal point. Something like that. And we could draw even more parallel rays of light. They would all come in and hit the focal point just like you found in your lab. Now, to do this for a real object, let's look at this tree. There are easy rays and there are hard rays. And I want to show you the easiest ones. So again, like we talked about last week, there are a billion rays of light, billions and billions of rays of light coming off the top of this tree. Some this way, some that way. Some actually come and hit the lens. Let's look at the easy ones. The first easy one is one that comes in parallel to the principal axis. This should not come as a surprise to you. And I'm going to draw it right to the middle of the lens. Now I know in reality this is what's really happening. It's really bending at both surfaces. But I can use a little trick here. I know that a light ray that comes in parallel goes through the focal point. So I'm just going to use that trick. I'm going to have it go to the middle of the lens, and then it bends right toward the focal point. And there's your ray of light. Similarly, there's another easy ray of light. This time it goes through the focal point. From the top of the tree through the focal point, it hits the lens. And if you're paying attention at all to the things we've been doing in class, what we just did, you know that the light that comes through the focal point now is going to bend and go straight, parallel to the principal axis. Just like if I shine a laser backwards along this, if I shine it here, it would hit the lens and it would come out like this. It's the same idea here. A ray of light comes from the top of the tree, goes through the focal point, hits the lens, and it comes out parallel to the principal axis. And just like before, you only need 2 rays of light to find your image. So our image is going to appear right there.
Benjamin Dijon, please go to the attendance office.
Sorry about that. The image is going to appear right here, right where those 2 rays of light cross. And what's going to appear there? Well, the top of the tree is going to appear there. So the top of the tree is right here. Where's the base of the tree? Again, we're going to use the same tricks we did last week. The base of the tree is going to appear right along the principal axis, just like it did for mirrors. Light rays that go through the focal point come out parallel, so it's just the same thing. I have a base of a tree here, and the top of the tree where the rays cross, and there's my image. Now, what can we say about this image? This image is a real image. It's real because the light rays really do cross right there. That's why we drew real rays. They really go through the lens. They really cross right there. It's a real image. I'll show you a real image like this the next time we have class. Now, we can also see in this case, and this is tough to see, but this object is a little bit bigger, so it's magnified. And of course, it is upside down or inverted. There is a third easy ray to draw. There is one ray that goes from the top of the tree right through the middle of the lens, and it just keeps on going. And if you've drawn everything correctly, all 3 should cross in the same spot. Now again, with all of these, we know they really bend twice, once at each surface of the lens. But we don't have to do all of that. We can just know where they end up, and this is how it works. This is 3 of the rays, all billions and billions of them that come off the tree and go through the lens. They would all cross at this point. These are just the 3 easiest ones, and you only have to know how to do 2 to get the ray diagram correct and find out where the image is located. Now that's for convex lenses. Let's move on to concave lenses. This is a concave lens. It's caved in on both sides. And again, in the lab we did recently, we found that parallel rays of light come in here, and they all do the same thing. So I'm going to draw a parallel ray of light. It hits that lens, and just like before, we can take a look at this thing. We know that the ray of light is coming along here. It's this side. This top portion of the ray slows down before the bottom portion, and the whole thing bends slightly upward. Something like that. Comes out this side, a big fat ray, we can think of it as again, and the bottom portion speeds up because it leaves the lens before the top portion, and so the whole thing turns upward. It looks something like that. In fact, we know from our lab that this ray really bends away from the focal point. You can see how I've lined that up. So I'm going to draw the focal point and just label it F. That's the focal point for a concave lens. And similarly, I can draw another ray in the bottom. I want to try to make it as parallel to the principal axis as possible. And it's symmetrical. It bends at the first surface, it bends at the second surface, and this time again away from the focal point. Any ray that comes in parallel bends away like it's coming from this opposite side focal point. So how do you find an image with a concave lens, you do something like this. Here's this face. We're going to find the image of that face, which is the object. And again, I'm going to start with a ray that is parallel to the principal axis. And again, I'm going to go to the middle of the lens because I know the trick here. I know it bends at both surfaces, but I know in the end it comes out going away from the focal point. So I draw it to the middle of the lens and away from this focal point. Now, this is the toughest one of all the ray diagrams. This is probably the toughest one, the toughest ray that you're going to do. There is another ray, and hopefully you've caught on. We have parallel and then through the focal point, or from the focal point. The next one is going to be toward the focal point, but we've already used this focal point, so we're not going to use it again. Instead, I'm going to aim towards this one. There's a ray of light that comes from the top of the object. Looks like it's going right towards this focal point on the opposite side. And just as we've done all along, it comes out parallel to the principal axis. Something like that. Now, your eye looks at these two rays, and these do not cross. Obviously, this one and this one are never going to cross for real. But your eye, remember your eye, not so smart, it thinks that this ray only travels in straight lines. It doesn't know that light can bend. And so it thinks that this ray came from way back here. And it thinks that this ray came from behind the lens as well. Where does our object appear? It appears right here. And what appears there? Well, these rays came from the top of the head. Your eye sees this ray, and it thinks it's the top of the head. So this is the top of the head, this is the bottom of the head, and there's our image. There is a third ray. I'm not going to draw it because it's a little confusing, but there is a third ray just like before, a ray that goes through the middle of the lens. And if you've done everything correctly, it should line up with the top of the object, or top of the image. It goes through the middle of the lens and it just keeps on going. Your eye looks back at that ray and it thinks it came from here. Again, you only have to know 2 out of the 3 rays to get the image location correct. And so I'm just going to draw 2. Don't forget, you need to go to the Google form and answer a few questions there to get full credit for this. And make sure you have this sheet completed when you come to class. And I can give you full credit for watching the video and doing the notes. You have to know this stuff before you come to class next time so you're ready to do the next assignment. My favorite candy bars are Twix and Take 5.